Ram, if you would, please.
Sure. Thank you, Beto. This is Ram, Industry Director with Frost & Sullivan. We are here today to talk about the Industry 4.0 and how it's enabling success and transformation across different manufacturing industries. And today we have two exemplary examples from Dow Chemicals and then Albemarle Corporation. These are two leading practitioners of Industry 4.0. So get ready to just listen to how they've implemented Industry 4.0 principles, analytics within their operations, and real-world case examples with real-world benefits on how they've overcome challenges and experienced incredible benefits within their operations and processes. So with that, let's move on. This is sponsored by Northwest Analytics. It's one of the leading Industry 4.0 manufacturing analytics solution providers. And Frost & Sullivan has a practice of analyzing key companies across the space and evaluating them for best practices. We do this on a regular basis. We analyze market spaces within manufacturing analytics and offlate the industrial IoT and the whole aspect of digital manufacturing. So we've looked at a spectrum of companies. We evaluated their strengths, weaknesses, best practices, who they're working with, what they've implemented, what are customers experiencing from implementation of the solution. And we recognized Northwest Analytics with the 2018 Best Practices Award for Manufacturing Analytics for Industry 4.0. It was a Technology Leadership Award because the technology was very strong, very sound, and they've been working with a lot of Fortune 1000 manufacturers to help them have an aided decision-making process on the process side. So that's Northwest Analytics for you. So today's agenda is going to be more in the lines of between the three people. That's myself, Ram, and then we have Lloyd from Dow Chemicals, and then we have Jonathan from Albemarle. We'll be shuffling back and forth on our slides, but the main points that we'll be covering are: why is manufacturing analytics a requirement or a prerequisite for Industry 4.0? Industry 4.0, as you know, is a process to create smarter products and smarter processes. But the fundamental requirement for Industry 4.0 is analytics and data. And you just can't do anything with data. You need analytics to make sense of data. So that's the first topic that we'll attack. The second topic that we'll attack is what is really the difference between foundational analytics versus later stage analytics? There is a lot of confusion in the market space on what analytics package should I be using. Is the one that I'm using sufficient enough, or should I be adopting something more deeper, denser, and should it be fit for purpose? So those are things that we'll be answering in the second section of the agenda. The third one is where we'll have Dow Chemicals and Albemarle talking about how they implemented the solution within their organization, what are the experiences of success, and this will be the section of understanding the best practices and what journey these two companies went through and what benefits they experienced. More importantly, while you go through the journey, the single most important thing is who do you work with, what technology do you consider, which technology do you adopt, because the stickiness factor is very important. You can't really waste time in investing in a solution that may not be giving you the benefits in the long run. So choose wisely, work with your partners, and choose your partners wisely so that you have a longevity in contract and you have a longevity in benefits and stickiness in the kind of like outcomes that you want to derive from the process improvements. The last one, of course, we'll come back again to the real world results on what KPIs did the two leading practitioners of Industry 4.0 have experienced. And that's what we'll be providing you some hard knock use cases and KPIs. So let's start off with what's really happening in the industry. When you look at the industrial markets across process industries, be it oil and gas, chemicals, petrochemicals, mining, every industry out there is being digitally disrupted. A dumb oil field is becoming more of a smart digital integrated oil field. Batch processing of pharmaceutical is now being moving into the continuous process of manufacturing. And there is the underlying thread between all of this is digital and digitization and digitalization, and then ultimately digital transformation. So what's driving all of this? So we are in an era where there is a shift that's happening, and that digital era is driving, and it's driven by a need to shorten the time for data extraction to value creation. So we all live and swim in data lakes and vast amounts of data within our industries. But what do you do with that data is really the key point of differentiation between a practitioner and a leading adopter of Industry 4.0 and somebody who's just joined the bandwagon for the sake of it. So that shortening the time from data extraction to value creation is very important, and that's driven by four key things. One is convergence. It's been a very overspoken term these days. The worlds of OT and IT, which is operational technology and information technology, are converging, which is you would see the likes of the pyramid model of ISA 95 being transitioned to a pillar model, where sensors and field devices are becoming more intelligent and communicate directly to the cloud and directly to enterprise systems. That's what we call as convergence. The fluidity is there are two ways in which we've seen companies approach the journey of digital. One is either a top-down approach or a bottoms-up approach. We coming as Frost & Sullivan have a strong viewpoint that the bottoms-up approach is more successful because that's the source of the data. And if you don't correct the source of the data and you don't correct the quality of the data, then you're going to have like garbage in, garbage out situation. So we have to fix the quality of data first in order to, from the bottoms up standpoint, and then drive digital transformation across the enterprise. The third one is transformation. As I said, every industry out there is being digitally transformed. And if we talk to any process industry that are on the call today, you would say that we've been using sensors, pressure, temperature level, volumetric, gauge, and so on and so forth for over 30, 45 years. So what are you talking about Internet of Things? What are you talking about industrial Internet of Things? Yes, you've been collecting data, you've been using sensors, you've been monitoring your processes, but the convergence of different kinds of data, the convergence of the ability to correlate different forms of data to arrive at unique outcomes and fresh outcomes that were never really possible before is what we're talking about as transformation today. The last one is new business model. I think this is the single most important thing as we talk about digital, because digital is going to give way to completely new forms of conducting business. Because earlier we used to own cars. Today you can subscribe to cars, where you can subscribe to an automotive vehicle. So similarly, within the industrial paradigm too, we're seeing the asset ownership model shifting from I want to own the asset, I want to control the asset internally, to more of I subscribe to the asset, I'll subscribe to the performance of the asset, and I'll pay a nominal fee to the OEM or the service provider who's providing me that quality of service. So that's the technology convergence is what we're seeing as it will drive a creative destruction and expansion of traditional business models. And that is something very important for all of us to consider. And, if you'd like, I can explain a lot of use cases that we've seen in the industries and how people are shifting their ownership models to subscribership models. We'll go to the next slide on, so what's really the enabling technologies that's driving digital transformation? So we have about 13 technologies here. And this must be familiar to most of you. When you embark on a digital journey, it's not necessary that you have to have every one of these within your journey, but keep in mind that these are some of the most common prolific digital technologies that we have seen being used across industries as they pursue in their digital journey. So this is coming from a list of about, I think about 60 to 75 technologies that we analyzed, and then we spoke with companies, we polled them, and we understood that these are the top 13 technologies that is helping companies to drive the digital transformation. It starts with ubiquitous sensing to predictive analytics, artificial intelligence, and machine learning, which is where the data gets converted to insights and insights gets converted to outcomes. And we also, Frost & Sullivan has a very strong opinion about the edge. We believe that within the industrial markets, 30% of all applications will be processed at the edge within the next 5 years. And edge is is the next big thing within the automation, process control, and manufacturing software market. So while we talk about all of these technologies, I would like to ask about Lloyd from Dow Chemicals on what he sees from his next slide, on what he can talk about what he's seeing within Dow Chemicals, and then how he's driving the utilization of data within his company. Lloyd, over to you.
Okay. What we were trying to do, which you addressed in your transformation and fluidity comments earlier, is that the amount of data that's available to decision makers in operations is significant, but the manner in which it is presented to them historically in the company was not sufficient to the types of decision making that we needed to make. In our operations, if we were to experience a problem today in a plant or in our recent history, we could easily go back in with higher order analytics and try to figure out how we got into that situation. But the reality was, is at the time we were learning how to do that, we also recognized it would be nice to be able to apply those types of analytics in advance so that we could avoid the situation altogether. The graphic in front of you merely illustrates the fact that while in my process industry and also in Jonathan's, we've been collecting huge quantities of data for generations within this industry, it continues to expand and grow. And so the problem that we saw in the 2000s and the 2010s is only going to get worse. And so in order to be able to do a better job of managing our data, we needed to start working on processes that would help us to manage that flow of data and make better decisions. There are many different types of decisions that we'd like to be able to do. The transactional is what everybody's aware of in most manufacturing industries. We make a decision based on the next data point we see. However, in a lot of process industries, we have different roles and different expectations in these roles to make different types of decisions. So therefore, if we want to bring an analytics program into manufacturing, we would like to be able to use it on many different levels and using very, very different data streams available to us to make different kinds of decisions. And so we've created this little pyramid of transactional, which is what everybody recognizes as the minute-to-minute or day-to-day decisions, and then the types of decisions we make in larger course corrections within, for example, a chemical process, operational decisions across multiple integrated processes. And then, of course, our business leaders would like to be able to take a look at the even broader data sets across larger footprints globally. And so we were looking back in around 2009 or 2010 how to get ahead of our explosion in data and the coming tidal wave that is now termed by the Germans as Industry 4.0. And this is one of the key types of capabilities we were trying to install. I think it's appropriate, if you want to go on to number 10, is that the in this discussion about analytics in the world, people are falling in love with the V's, the volume, velocity, variety, and veracity. I understand now there are probably 9 or 10 V's. I don't know what the other ones are at this point, but I've seen some reports about this. Volume is a bunch of data. What do you do with it? How do you, and then the velocity and data in motion, how do you start making real-time decisions based on the data that's coming at you? Variety speaks to data beyond the integer types of data analysis we are used to using. Data in my company now also refers to unstructured or textual information, and how do we start to bring that together? Of course, in customer databases and things like that, people are putting free-form comments in. We'd like to be able to master that. And throughout all of this, we have to apply veracity. We need to understand how good is our data, how accurate is it, how reflective of what is actually happening, whether it's structured or unstructured. So we have a lot of interest in the academics around data use and how we start to bring these various forms together, which I believe was used as the term of transformational that you described earlier, where we want to bring really unusual and very different types of data forms together to be able to create new types of decision-making processes moving forward.
So while Lloyd gave a good overview about what this is on, what is being used within Dow Chemicals and how different kinds of decisions are being made, it's a very important thing to understand within process industries, because KPIs vary. In one of the slides, you talked about transactional data, tactical data, operational data, and strategic data. There is immense difference between a KPI that a C-suite wants to look at and an operations person wants to look at. So we see that there is a disconnect between the two. And there are some solutions out there which really helps companies realize how to have custom-made, fit-for-purpose KPIs at each level, and then drive efficiencies across the enterprise from the operation side to all the way to the C-suite side. So we move on to the next section, which is foundational versus later stage analytics. Here we talk about what should you do and where should you really start, and we're going to give some practical examples on what we've seen from Frost & Sullivan standpoint as an analyst firm and consulting firm, and then we'll hear from Dow Chemicals and Albemarle on what they are and where they are in the journey. So if you go to the next slide, we have a simple framework which is called as the this should be very familiar to a lot of you people on the call. We've seen the progression of analytics platform, but this is customized for process optimization, because this could be applied pretty much on an asset performance management model too. But we're not talking about condition monitoring of assets here, but we're talking about process optimization within the industries which have complex processes where you change a variable, your product quality could suffer. So what do you do and how do you measure what data you capture to ensure that you have consistent product quality at the end of the production line? And this is very much applicable to areas like chemicals and specialty chemicals and refining for that matter. So we see within the market space that you start with preventive, which is regular process issue management, probably in a reactive way, and then you move into a proactive decision-making process where you use monitoring and diagnostics in regular intervals, which could be schedule-based, and then that can be used to detect critical process issues. Right now, we're looking at a wave of predictive analytics where you're using streaming sensor data to predict what could go wrong. And then it could be based on historical data, it could be based on error data, failure data, and then service that asset or service that process so that your end product or end product quality is really not suffering and you're able to meet up and keep up with your commitments. The last stage is prescriptive, which is the holy grail of analytics, is what we would say. We're still about 5 years away from it. There are some solutions available in the market space today where you not only analyze the data, but you also prescribe what should you do if a possible issue like this happens within your industry. So to Lloyd's comment, and coming back to Lloyd's comment again, where there is a significant shrink in experienced workforce across process industries, we've seen many numbers like 50% of the workforce is eligible for retirement in process industries on the oil and gas side, which is across upstream, midstream, and downstream. I don't know the numbers specifically for chemicals, but I've heard myself speaking with chemical companies where they said we used to have 10,000 process engineers. Now we are drawn to about 1/10 of that size, but the amount of technology complexity has increased tenfold. So how do you manage all of this? What do you do with that? So you need to automate some part of the business process, and you need to intelligently and smartly behave to get the data that used to be crunched by humans before, but now it'll be done by machine learning algorithms to get you where you want to go. So this is where I want to turn over the stage to Lloyd and Jonathan. And Lloyd, maybe you can start off with and explain where you are in this journey. What are you doing within Dow Chemicals so that the audience can have an understanding? Thank you.
So in that previous slide, this is our interpretation of what was just shown to you. Typically, by the early 2000s, our operations were mostly focused on reporting what happened and going back and analyzing why did certain things happen. We took a path towards being more proactive in the data, showing it in a different way through a series of dashboards and processes that allowed for people to be monitoring larger, more streams of data simultaneously and having a system that's watching that data and helping to alert us to those anomalies. But then we wanted to stack on top of that two other things that would allow us to start to determine what might happen in the near future and what's more likely to happen in the further future. The prediction element that is the second from the top really speaks to applying fundamental models. There are programs out there by companies like Aspen Tech and other suppliers of technology that are based on applying fundamental engineering models to a given operation, especially in the chemical and process industry. Simulation speaks to empirical modeling. That is taking large data sets and looking for signals that are the correlations or anti-correlations between data sets and learning that those changes in those interactions are very early signs of problems that may be cropping up that would not become evident either until very soon before the problem was going to start causing you operational issues, or might not even be evident until after the problem has already presented itself and you're going back through the analysis phase at the bottom and looking for it. So we're looking to enhance in the first two boxes at the bottom, real-time monitoring now, and then move towards application of a broader tool set of prediction and simulation that everybody in the plant can enjoy, not just a specially trained engineer. This picture we like to use because, to be honest with you, this is the what's happening now slide. This is actually real data where a plant was operating normally. I think you can tell when we first started to turn the program on and have people looking at it and also having people react to it, that all of a sudden the violations started to fall, and you can tell that it took a couple of weeks for people to get used to the program and know what to do about it, and then everything's working fine. In the previous paradigm, data like this was entered by pencil into numerous logbooks as control charting. The problem is that manual control charting doesn't allow you to take a look at large sweeps of the data, and it doesn't come back, the control chart on paper doesn't come back and alert you to a systematic historic problem. But as you can imagine, in this very simple example, bringing real-time analytics to this particular operation had a dramatic effect, not only on product quality, but on safety, on the use of the plant and running the plant within the design parameters, and allowing people to have real-time information that allow them to make better decisions. This can also go to a much more complex view where we go ahead and run it all the way through, where we have we call this chemometrics or multivariate analysis, but you have two univariate measures, and everything within those red lines means the product's perfectly good to go. But if you do a correlation analysis, which is a little bit higher order analytics than the previous example, you find out that the data between these two usually correlates very well. That's within that little green orb on the lower left-hand box, but this one particular lot of data is not correlating. This is the type of things we want to remove from our supply chain, because while it is within spec, because in the univariate measures, it meets both requirements, it's sitting outside of what we would consider to be a normal correlation or a normal product line. And so not only do we go back and figure out how that happened, we can avoid insulting any of our valuable customers with something like this. Before we started instituting this type of data approach in our plants, before we started doing that, we did not ever see that data, and we did not know that we were doing this. And so we've taken a grand program of instituting that type of analytics. Okay, so yes. This is a 9-dimensional model of 9 dimensions within a particular product that we would like to sell our customers, and it demonstrates to you that we can now tell within those 9 dimensions what is fully conforming to the process capability and what is not, and allows us to go in and clean this out, re-engineer, redesign, and re-parameterize our process so that we can improve product quality, process efficiencies in approaches like this, although these are in some cases pretty sophisticated pictures. I think the next one, Jonathan, is yours.
Yeah, I got ahead of myself. Okay, yeah, so this is just a chart illustrating how quickly you can see results and see improvement, and things don't happen instantly. And so I believe this timeline is right about 6 months to a year. And right in the center is where we implemented some of this just univariate analysis, where you're doing a real-time control. And historically, when we would look at this data, you look at each one of these data points individually just as a number on a sheet of paper. And in our control rooms, we would get this printout with these data points, and you just have a number. You know, the number would say 200. And if 200, if you felt good, the last number said 200 as well, you probably consider it good. And if you saw 260 or something, you'd probably take another sample and wait for the next result before you made a change. And so what this did is kind of put things in perspective and allowed us to, right there in the moment, make changes where we typically kind of just delayed it off to the next shift. And so over time, when you do that, you start seeing you don't have to overcorrect quite as much, and you start making less changes, and then just by natural course, it just happens to where you just slowly start getting tighter and tighter control. So if you go to the next slide, that was kind of like in the past. And so now what we're doing is like what Lloyd was doing is getting into the multivariate space, but real-time multivariate. And so typically we've done this a lot too. Is do these, you have a problem, you know, a customer contacts you and you have some weird chemical species that, you know, is fouling some part of their equipment. And so you have a whole team of engineers and chemists trying to figure out what it is. You're going back looking at old data, trying to paint this whole picture, because everything that you sent the customer was in spec. And so what we're trying to do is take some of that knowledge and apply it live. And so if you see the picture of the, this is kind of a live picture of what we do when we're looking at trends and batch data. And this is how some of our, you know, different reactions are occurring. And we're trying to summarize that entire screen, all those different peaks and different colors and different time series data, and you summarize it into one single data point, one single red block. And then that you're summarizing so well that the operator can then go in, look at it, and based on how you summarize it and the instructions that you've given them, they can make a decision to fix that problem before you have to have a whole team of engineers 3 months later and angry customers calling you to complain. And so that's the transition that we're making at this moment.
Interesting. So that was a great overview from Dow Chemicals and Albemarle on how they've transitioned from what they were doing before to what they're doing now. And it's in line with what we've also seen in the market space on technology transitions and technology transformations. So now we move into the next section on what does it take to be digital? How should you really look at a digital organization? And what we did was, and in this case, I would like Lloyd and Jonathan to comment on it as well, is we have designed, like Frost & Sullivan has designed a digital transformation maturity model. So we've seen a lot of customers use this model to benchmark themselves against where they are in the process of digital transformation. And if I go to any companies in the chemical space or oil and gas space, they might say different parts of the company are in every stage. It's not that I can bucket myself into one particular stage, which is completely fine, because we as an industrial market are not mature enough to say my company is completely in stage 3. Within a company also, if they have 100 plants, 20 plants may be in stage 1, 50 plants may be in stage 2, and 50 plants may be in stage 3. So what we really see is stage 1 is digitization, where you look at measurement of the process indicators, sensing of those operational applications, operational metrics, and then data integration of it to reach into stage 2, which is digitalization part of it. Digitalization is what do you use with what do you make use of the data, and then how do you arrive at insights in stage 2. And stage 3 is how do you make use of the insights to arrive at outcomes and then transform your enterprise inside out. There is something called a stage 2.5 where I think Lloyd and Jonathan also talked about. Whatever data cuts you do and whatever data analytics you do, if you don't represent them, like Lloyd's point is a picture is worth 1,000 words, that visualization of data and driving that KPI alignment between plant floor, engineering, and corporate, that's fundamentally important in stage 2.5. A lot of companies miss out that stage, and I want to open that up to Lloyd and Jonathan to comment on what they think about this model and where they think they are in this journey to digital transformation. Lloyd, you want to go first?
Yeah, to your point, we are all over the map. It really depends on where we point our view on certain things. But if you could go to the next picture, I wanted to share with everybody a page out of Analytics at Work, which is a book by Thomas Davenport and Janine Harris. It's Davenport and Harris. It's the companion to their first book called Competing on Analytics. And unfortunately, I read Competing on Analytics about 7 years after I started down this road for Dow. Had I read the book before I started down this road, I think I would have found a different job in Dow, because it turned out to be very prescient on all the challenges it would take to get any company down the path towards being an analytical competitor. But I like this picture, which sort of mirrors what was shown in the previous slide, but it's really focused more on the data and the analytics enterprise within a company. You have they posit 5 different success factors, and then they have 5 different stages from analytically impaired to analytical competitors. And my team that I formed early on in Dow to get started on this process, we officially ascribed ourselves somewhere between stage 1 and stage 2 on each one of the success factors listed there, and you can take a look at them while I'm going over this a little bit. I think by the time we started to implement some solutions within certain manufacturing areas and get the attention of our senior management, we felt that we were making way into stage 2 of localized analytics and then stage 3 of analytical aspirations. With Industry 4.0 and some significant support from leadership within our company, we now can confidently say that we are probably within the analytical aspirations and are moving in to stage 4. But if you read some of the elements of what it takes to be an analytical competitor in data or leadership or analysts, we aspire to these things, but in certain areas in my company, we are quite there. In other areas, we have a lot of ground to make up in order to get to this point. Within our process industry in general, the chemical industry, because we are a very old and well-established type of capability within the world, I mean, back to 1870, I think, when BASF and Bayer first started up in Germany, I think our transformation as an industry has been a bit slower than it could be. Clearly, the Amazons and the Googles and the commercial programs that have developed in the world in the last 15 years, they started from a different footing and got into the stage 5 a whole lot quicker, because we have a lot of culture to overcome, which also is described in these books.
All right, and I can add a little bit to that from the Albemarle perspective is, we have a lot of plants, worldwide, and they struggle with this. And, most of them don't even have, trends that they look at as far as just going back and being able to look back at old data. And some of them don't even have LIMS, lab analytics. And so it just kind of depends on where you are on this train. You can't take somebody that doesn't even know how to use Excel and go and bring them into this multivariate space where you're trying to do real-time control. And so typically you have to find those pockets in your company and you just bring them to the next level. And so if you have somebody that is already advanced, use them to do the advanced things. And then over time, those trickle down quite rapidly down to the other areas. And we even have, like right now in our stuff in South America and in China, our big focus is bringing their safety level up to our level. And those are things that, you know, historically they haven't been really pushed in that arena like we have in the States. And so that's been a big struggle. We've taken a lot of resources from our U.S. sites and brought them down from a safety perspective. And we will be doing the same from a data analytics and operating perspective as well very soon.
Jonathan, that's great, because the next slide is we call analytics culture change. And the main point of this particular graphic is that in any enterprise, you have a small group of people that have very high levels of analytics capability, and how on earth do you start to scale that across the company? This picture was actually used for a completely different reason. My company and some other companies that we're partnered with in various types of professional venues are trying to elicit a culture change in how analytics is trained and introduced to our college workforce, or the potential workforce of the future, trying to get colleges and universities to change their footprint. But you know, if you think about it, analytics is all about the art of the possible, and we need to do as much as possible to get people in a mindset that there's more in their data and more analytics than historically they've been exposed to. And we certainly want to improve people's data literacy and acuity, and also then further improve their data acumen. And we're not going to make everybody in our company or everybody in the world advanced data scientists, but we do need to improve this broadly, and we've taken steps within Dow to do this specifically. We are taking steps with other companies to do this broadly in university systems, and we're also wanting to make sure that everybody starts to understand in the art of the possible what data analytics can do for them. And you don't have to be an engineer or a plant operator to gain advantage from this. This is something that we're working on more broadly.
We move on to technology considerations in terms of what does it take to build an analytics culture. So when we look at technology considerations, again, we design this roadmap on how customers are going digital from the past to the future. So this builds off the framework that we provided to you in the digital transformation journey. So in the past, we've seen companies being very process and products focused across the spectrum of process industry side. It's commoditized, and they were working with multiple suppliers. Even today, when we walk into a plant, I'm sure Jonathan and Lloyd, you would agree that there is just multiplicity of platforms, multiplicity of sensors, multiplicity of control platform makes, and multiplicity of software platforms that you use. Any comments on that, Jonathan, Lloyd, on where we were in the past?
Yeah, they are. And by the way, there's certainly good reason to have different types of systems doing different things. This slide here was simply to impart to people in my own organization and outside that we have a specific intended use for the analytic decision making that we want to get. Deliver data and statistics for data-driven decision making, automated early warning systems, system to capture learnings from the use of that data, and a tracking system for leaders. We have systems in our plants already that do advanced process control, plant optimization, and we are not trying to, in this particular project, improve those systems. However, we do obviously have people that are working on that as well. And in the future, all of this may come together in some process. But we would like to improve our decision making, and if the systems in place in our plants today are not giving us the best performance on our data decision making, this is why we would bring in new tools to enhance that.
Perfect.
Yeah, and
thank you.
I can add.
Go ahead, Jonathan.
On the in the plant, you have so many different instruments and so many different sensors by so many different manufacturers, different time periods, and the site that I'm at right now was built in the 1950s. And so you're pulling data from instruments from the 1950s in some aspects. And so when you're getting on this journey and you're trying to utilize that, that's one of the reasons why it's so hard to implement some of these things in manufacturing, especially in chemical manufacturing, and oil and gas is that there are this huge variety of data, and you have to understand your data. And so if you have a flow meter that's 50 years old, and it's got it's offset a little bit and has a lot of noise, and maybe you have a valve that isn't opening all the way, and it's causing you some weird feedback. That's where involving those people that are on the plant floor and putting the information in front of them is important, because if you just are in the office at all times looking at this data, you can't have a data scientist do this by themselves. And that's where getting that real-time input, not only from engineering perspective, but from an operations and operator perspective, adds a lot of value.
Absolutely, Jonathan. That's a great point. I think, Peter, if you go back to slide 26 again, that's the last stage of digital maturity that we're seeing within customers, which is you look at the current state is IT/OT convergence and OT applications, but then the future is exactly what Jonathan said and Lloyd outlined. It's process outcomes as a service, where you provide self-serve analytics to operators, and then you give outcomes-based services to them, and you provide a high level of intelligence, a high level of specificity on what's wrong with the process, so that it's very seamless. The user experience is extremely intelligent, and that's essentially where process industries are migrating towards to battle with the decline in the experienced workforce. So let's turn it over to Lloyd to talk about where Dow Chemicals is within the journey, and then Jonathan, please feel free to add comments on what you see as a future, and how do you see as incorporating analytics as an enabler of that future state of vision.
Okay, Peter, I guess slide 28 real quick. This is just a picture, a graphic of an organization of all of our data within an operation and being able to use it in many, many different ways, but viewing it in a completely different way. Typically, things would be sitting in the lower right-hand corner with a GPI screen with a bunch of data plotting across multiple axes, and your brain was having a hard time managing that, and no system was actually analyzing the data itself to give us a sense of whether it was trending out of control or there was something wrong with the data. With the type of technology we've used from Northwest Analytics, we've managed to get a handle on that, and we're now able to contextualize our data both for the operators in the lower right-hand corner and for our senior executives in the upper left-hand corner, as we go from the top of the mountain down to organizations that are assigned to help manage the technologies we run, down to the improvement engineers within our operations who are working on our plants at a higher level, and all the way down. And all of this data is managed real time, and we can very quickly parse what information we want to look at versus what we don't. And this is the state of our current implementation in and represents an opportunity for some plans we have in the future.
Thanks, Jonathan. Thanks, Lloyd. Sorry, Jonathan, could you please cover slide 32 and 33 for us? That's an interesting slide, and it's exactly in line with the discussions that's running now.
Yeah, sure. So I'll kind of give a overview of really what we used to do in the morning. So we actually, at the current site I'm at, we had our process supervisor would get at the plant at 5 a.m. and we would have our first tailgate at 7 a.m. And for 2 straight hours, he's going through trends like this. And this is just one kind of overview, but he's trying to get an understanding of the entire plant operating, I guess, overnight, or if it's on a Monday over the weekend, trying to understand what happened, what things changed, what does he need to fix, what does he need to work on. And so he's spending 2 hours every morning, and then he has a whole list he goes through. And then our foreman that's out in the plant running on shift, they do the same thing every single day. And so they're going through, they have a list, and each day those lists change, or the guy didn't get enough sleep, and so his list isn't as big today, he didn't care as much. And so things are getting missed, and things are getting looked at that don't really matter. They don't have any statistical significance. And so we're using a bunch of this clutter to try to steer our process and steer our operating time. And this is where we're spending our time. This is what we did. You go to the next slide, is we kind of shifted back towards taking all of that cluttered data and simplifying it. And so when in the morning, he comes in now and he just goes through this. And typically he would spend, if it's green, it kind of means, hey, there's no issues. Don't worry about it. Go to the issues of today. And so he goes to the red items and he starts, okay, here's the issue. But the good thing is that this data is in the control room, and this data is being utilized by the operators and the foreman that was on the night shift before. And so typically this data was never looked at, or if it was, nothing was done actionable about it. And what we're now getting into is that the operators are seeing it on nights and weekends. They're looking at the data at the right time, in the right way, and they're going in there and figuring out the problems. And then they've already, either if it's a valve that needs to be replaced, the work order is already in, and maintenance is already got a permit at 7 a.m. ready to go pull the valve and replace it. Or they know that, hey, we need to change this set point to adjust for a new raw material or something. And so he's coming in on Monday morning and he's just checking off his list on, okay, they've already solved this for me. They solved this. And then there might be one or two kind of outlying that they couldn't solve overnight on weekends. And that's where you start getting some of the engineers involved in getting a bigger team and elevating the problem. But this kind of takes all that art form and that mystery away and really gets down to solving these problems when they happen. And that's how you get that return on your investment. And that's how you start seeing just slowly these things just naturally have this progression, continuous improvement.
Peter, if you could go to slide 35, I can continue on Jonathan's points. Jonathan showed you where he was and where he is now. Here's another way of looking at that. The first time we turn on any of these tools, and Jonathan sees this in his plants as well, we see what we see on the left. That's run plant normal, but that's a look at the data that the operators and the engineers have never seen before because it was not made available to them. And then over a period of a couple of days to a week or more, we can work those data streams and work the processes back to within the parameters that everybody agreed is most suitable for the plant. That's what Jonathan does at Albemarle right now, frankly. And from left to right, it's the same plant. You can accuse the plant on the left of not having the proper operating discipline, and I will tell you, no, it's the same plant, it's the same people. It's giving them a better view of their data. And if you would then go to slide 38, Peter, I have a point here which is a little bit morbid, I guess, but we have processes in quality assurance and process monitoring that were designed in the 60s and 70s, and we started using Excel and some what we now consider primitive tools to manage those, and we're still managing those into this century. But in the era of Industry 4.0, digitalization, and the IoT, my point in this slide that I show people now is, does it make sense that our current and traditional process is the way we do things? Because we're trying to get in front of the data and anticipate things versus sending a process through to the quality lab and finding out after the fact, gee, were we actually successful in what we were attempting to do? I would like to adopt the Toyota model of making cars where we're certain that we are successful as we drive the product off the assembly line into inventory.
Yeah, and I can add to this slide. From an operations perspective, they do it, and even to a greater extent, they utilize the tools that you give them. And so if you have Excel, that's why all the engineers gravitate towards Excel, because they can, they know how to use it. They've used it at their last job, and that's kind of what they have. And when you look at an operator and you're trying to say, hey, I want you to understand everything about this process, and I want you to make sure that, like Toyota, you're getting our product out there right the first time, and we understand why we did it. And the tools you give them are a pair of channel locks and some duct tape. And that's what they're trying to run your plant with. And I actually had, when I first got to this site, we had this problem where one of our furnaces was kind of going back and forth and chattering a lot and having a lot of shutdowns. And we looked at it, and one of the control valves had a lot of noise. And okay, well, I'll just tune the control valve, no problem. And I tried to start tuning it, and it wasn't responding right. And I was like, it's kind of weird. So I went out and looked at the control valve, and there was a bungee cord attached from the control valve, the linkage piece, like to a piece of pipe next to it. And so I guess it was chattering in the past, and the operator thought it'd be a good idea to go take the bungee cord, probably something he found on the way, and, get rid of that chatter by just kind of bungee cording it to a pipe. And that's the tools that we give them. So what we're trying to do is get away from that kind of old process, I guess the morbid piece, and give them the right tools and the right information at the right time to solve these problems in the right way. And so on this slide, I can talk.
Jonathan, I just had a point. While we talk about on that same line, could we have you and Lloyd talk about the ROI that you got before using Northwest Analytics and what you experienced after using NWA? I believe you have a couple of slides on that, and then we'll move on to Q&A. Yeah, please go ahead.
Sure. I think, the biggest thing, and we talked about it, is the visualization. And so, and this is a hard thing for people within my own company to grasp. And you say, hey, I'm doing some, univariate real-time SQC things. And they're like, oh, yeah, well, we're doing that too. And you ask them, well, where's the return on investment? How's it worked out for you? Like, well, we're doing, statistics. We're using statistics in our plant. You're like, yeah, but how is that working out for you? What's the value? And they don't really have an answer for that. And so typically in the past, we've had SQC charts for a long time. Actually have in my office right now from 2003, a scroll printed out of laminated SQC charts that, one of the old engineers had created and probably spent a lot of times creating. And then you ask them, well, what was this for? And they're like, I don't know. We just had to create them. And so we've been doing this for a very, very long time, but it hasn't been put in front of the people that make a difference. And so that's the whole key. And so as soon as you start just putting that data that you already have there, and you already kind of understand how to analyze it, it's putting it in front of the people, the right people at the right time, in the right way, and giving them the tools they need to solve those problems. And then boom, it just starts happening like this. And I have tons of slides that are just before and afters of, and this happens within 6 months. And this is actually like final product that we send our customers. And so when we very first started, we probably, it's like the whole Six Sigma approach, and you just slowly start tightening your, final product. So some of the things that we do is, I think we're at the new operating ranges slide. So some of the things we do is we adjust and we shift up our, we say, hey, we've been running in this space for a long time, and we start asking questions. Well, why are we doing this? Why are we doing it this way? And you're asking the right people at the right time, and then someone has a suggestion. Hey, well, why don't we run it like this? And you try it, and then you say, okay, well, this is our new normal, and that's kind of what's been happening. And then if you go to, I think the next slide 43. Yeah, and so this just shows different space, and you can see the after is a new range, but it's also a tire range. And so not only are we just discovering new spaces, but we're also discovering how to control within those new spaces better than we ever have before. And then the result from that, if you go to the next one, slide 44, is the reduction. So we actually made those adjustments to improve our product quality with no concern for cost savings. And what we found, and this is where you get your ROI, is that you're just trying to tighten your control limits. And a lot of these things, we spent zero capital investment on actually fixing these problems. It's just like paying attention at the right time, doing the right moves, and then rediscovering really where you should operate your facility. And then because of that, you're operating your facility more efficiently. And this one example is roughly $500,000 in annual savings from just making this quick transition.
Very interesting, Jonathan. Thank you so much for that. In the interest of time, we have about 3 more minutes, and I do have a few questions from the panelists as well. Before we move on to Q&A, all the participants in the call today, you're welcome to join the conversation and continue the journey on manufacturing analytics. There are 2 forums that Northwest Analytics has arranged. One is in Houston, Texas in October, and the other one is Antwerp in Belgium in November. There are websites for your reference. Please feel free to go ahead and look into the agenda. There are a lot of keynotes that's happening there, and then enjoy and just be on the journey for manufacturing analytics. So from a question standpoint, the first question that I have for both Lloyd and Jonathan is, what's the bigger challenge getting to success? Is it finding the right technology, or is it changing the company culture to embrace analytics? Lloyd, do you want to go first?
I think the bigger question is what problem do you want to go solve, and what do you need? What data streams do you need to go solve it? Then it's changing the culture. There is also the problem that everybody has a hammer and they want you to use it to work on your nail, and you don't have a nail.
Mm-hmm.
So, yeah, culture is a big problem. There's no question. But I think if you want to simplify it, figure out what you want to work on first and go after that specifically.
Thank you, Jonathan.
Yeah, I would agree. The hammer and nail analogy is great, and typically that's where you struggle. And the reason is not necessarily that these things won't add value. It's that sometimes people don't give you the necessary resources that you need to implement this in the right amount of time. And so if you have that nail, right, that's in front of you, then people in management and leadership is going to be giving you more resources, and these things are just going to happen faster, and you don't have to struggle quite as much. It's not that you can't, that you won't have value, but yeah, it definitely make it a lot more valuable, and your ROI will be seen a lot faster. But yeah, most definitely the culture change is the hardest part, and that's the thing that takes the longest. And I think that's with any kind of tool or any kind of change that you're trying to implement.
Sure. Thank you. Thank you, Jonathan. So I know we're top of the hour. We don't have time for all the questions, but please do submit them offline and we'll take it. These are our contact information on the slide for you. Even the recording of the webinar will be available offline, and then please feel free to access it and then get in touch with any of us. We're more than happy to answer your questions and then take things forward. Peter, any closing comments from your side?
No, that's all. I appreciate everyone's time. And as you said, we will make the link available to the webinar recording as soon as we can. Thank you.
Thank you.